Okay, so we are looking at learning objective 19, which is define isotope and relate how this changed Dalton's atomic theory. So one of the things that you should learn from your timeline project are the postulates to Dalton's atomic theory. Looking at is to define the isotope and relate how the isotope discovery changed Dalton's atomic theory. So an isotope is an atom of an element that has the same number of protons, but different numbers of neutrons, and therefore different masses. Mass numbers. The mass number is the number of protons plus the neutrons. So protons plus the neutrons is the mass number. So the effective postulate for Dalton here is that identical in size and mass. Now, we could say that atoms are identical in size because size has to do with the electron cloud, or where the electrons are located within the atom itself. So we can still say that atoms are identical in size. The thing that we cannot say, however, is that they are no longer identical in mass. We could say that they are identical in number of protons because that is the defining factor of an atom itself, is the number of protons, or the atomic number here. So again, here we go using those words, mass number and atomic number. Isotope form for elements. So we can signify a certain isotope by either writing the name of the element, dash, and the mass number. Okay, so for kind of exact example here, so for example, if I wanted to say like carbon -12, this is the most common isotope of carbon, or I could say C-13, this is another isotope of carbon, or I could say, I don't know, carbon -14. These are all signifying that I have a different isotope. So this guy is the mass number. And then this guy is either the name or the symbol. So I have the symbol here, I have the name here. It really doesn't matter. 40, calcium 40, that's signifying that calcium has a mass number of 40, or copper 64. That's signifying that copper has a mass number of 64, right? So carbon 12. So if I go back and look at like the number of protons and neutrons in carbon 12, so my protons are equal to 6, right? Because carbon is always going to have 6 protons because, again, carbon's atomic number is 6, right? So it will always have 6 protons. That's what makes it carbon, okay? You can't have carbon without it having 6 protons. The number of neutrons here are 6 as well, okay? Here, the only thing that has changed here, I have 6 protons, but I have 7 neutrons. So I've increased neutrons. And then here, again, 6 protons and 8 neutrons. Okay, so that is an isotope and what an isotope is. Now, we use isotopes all the time, guys. Like, I can't even tell you like how much isotope chemistry has come and how far it has come. I mean, if you think about it, it's used in medicine. It is used as radiation. It's used as like being able to see inside the organs. This type of chemistry is huge. It's absolutely huge. If you've ever drank like chalky stuff so that they can see inside your intestines, what you were taking were certain isotopes. So like certain amounts of a radioactive isotope is what you are taking. And that isotope shows the doctors what is going on inside of you and how your bowels are moving and how your intestines are moving. It's very, very interesting chemistry. It's very, very intense chemistry. Okay, so isotope, same number of protons, different numbers of neutrons, same element. It's the same element. As long as it has the same number of protons, it is the same element. Okay, so an isotope, if you have same protons, you have the same element. Okay, so same protons, same element. And that is how you define isotope, and you relate it to Dalton's atomic theory. So atoms of elements are no longer identical in mass. They are identical in number of protons.